The solar system you were shown in school was a lie. Not a malicious one, but a lie all the same. And once you see what it was hiding, you will never look at the night sky the same way again. You know the picture. 8 planets in a tidy row, evenly spaced, big and colorful, all sitting flat on the same page, close enough that you could almost hop from one to the next. That image is burned into your memory from childhood, and it is wrong in almost every way that matters. Here's what you have to understand. The real solar system is neither flat nor crowded. It is a 3-dimensional ocean of nearly perfect emptiness, with a few specks of dust scattered through it. And that emptiness is so extreme that the fastest thing in the entire universe, the thing nothing can outrun, struggles to cross it. Think about light for a second. Point a flashlight at the sky and the beam leaves the glass at 186,000 miles per second. Nothing goes faster, ever. And yet, as you are about to see, against the real scale of space, that beam behaves less like a bullet and more like a snail crawling across an ocean. So here is what we're going to do. We're going to take that flat schoolbook map, tilt it, and watch it fall apart into the real 3-dimensional void. You'll see why even light arrives late and exhausted. And by the end, you'll understand something most people never stop to think about. The universe is not mostly stars. It is mostly nothing. Stay with me, because the part about looking straight up is the strangest of all. Let me start with the flat map's biggest lie. It tells you the planets are in a row. They're not. On the diagram, they sit side by side, like you could walk down the line and visit each one. In reality, they orbit at wildly different distances, on slightly different tilts, scattered all around the sun in 3 dimensions. Right now, as you watch this, most of the planets are nowhere near each other. They are on the opposite sides of the sun, separated by hundreds of millions of miles of nothing. And that word, nothing, is the one you have to hold on to, because that map can never show you what is actually between the planets. So let me prove it to you in a way you can feel. Ride along with a single particle of light as it leaves the surface of the sun, heading straight outward. Watch what it actually crosses on the way. For the first 3 minutes, it sees nothing at all. Then it passes Mercury, 3 light minutes out. Then more nothing. At 6 minutes, it passes Venus. More nothing. At 8 minutes and 20 seconds, it reaches you, Earth. Which means the sunlight hitting your eyes right now actually left the sun before you started watching this sentence. And that leads somewhere unsettling. The sun you see is not the sun that exists. It is the sun from 8 minutes ago. So what would happen if the sun simply switched off? You wouldn't know, not for 8 full minutes. You would feel its warmth, see its light, suspect nothing, while you quietly orbited a star that was already gone. And our light particle is not done. It keeps going, past Mars at around 13 minutes, then a long, dark gap, far bigger than everything before it, until Jupiter at 43 minutes, Saturn at almost 1 hour and 20 minutes, then the deep outer dark, Uranus at 2 hours and 40 minutes, and finally Neptune, more than 4 hours after the particle first left the sun. 4 hours at the speed of light just to cross our own backyard. And in all that time, the light touched almost nothing. A few specks. The rest was pure void. Now, hold that feeling, because it is about to get much worse. We call the speed of light the cosmic speed limit, but there's something you probably never realized. It is not actually fast. It only looks fast because your world is tiny. Let me shrink the whole solar system down to something you can picture on a table. Say the Earth is a single grain of sand sitting in front of you. At that scale, light does not race across the room. It crawls. It moves about 1 step per second. To reach the grain of sand that stands for Mars, light has to walk, step after step, for several minutes. To reach the grain that stands for Neptune, way out at the edge of the table, light has to keep walking, 1 step every second for over 4 hours, through total darkness, never passing another grain. That is the fastest thing in existence. A lone walker in the dark, 1 step per second, crossing a table where the nearest objects are entire rooms apart. And you might assume the stars sit closer together than the planets. The opposite is true. Reaching the planets is the easy version, because the planets are our neighbors. The real distances, the ones between stars, makes this whole table look microscopic. Take the closest star to our sun, Proxima Centauri. It sits 4.24 light years away. So our light particle, the one that crossed the entire solar system in 4 hours, would now have to keep going. Not for hours, for 4 years and 3 months, non-stop through nothing, just to reach the single nearest star there is. And we have tested this with a real machine. Voyager 1 is the farthest object humans have ever built, flying outwards since 1977. If you turned it toward Proxima Centauri and let it cruise at its current speed, it would take about 73,000 years to arrive. 73,000 years to the nearest star. That is longer than our entire recorded history, many times over. So now you have to be wondering, why can nothing go faster? Why is light stuck at this maddening crawl? The honest answer is stranger than a simple speed limit. The speed of light is not really about light at all. It is the basic exchange rate of the universe, the fixed link between space and time, built into the structure of reality itself. Light just happens to hit that maximum because it has no mass to hold it back. So the number is not a wall someone built to keep you in. It is simply the grain of the universe. And the universe is enormous, while that speed is fixed and modest. Too much distance, only one speed to cross with it. That mismatch is the entire reason space feels so unbearably empty. Now, remember the strangest part I promised you. So far, we've only looked sideways, out across the flat plane where the planets live. But the planets are trapped on that plane. You're not. You can look up, straight up out of the disk, toward the North Pole of the solar system. And when you do, the emptiness does not just continue, it gets dramatically worse. Think about why. Out along the plane of the planets, at least there is the occasional speck to break things up. A planet, the asteroid belt, a distant comet, thin company but company. Now look above and below that plane. That thin company vanishes. There are no planets up there, no asteroid belts, almost nothing at all to interrupt the dark for an enormous distance. So picture this. You're standing on the sun and you fire a beam of light straight up perpendicular to everything toward the empty north of the solar system. Where does it go? What does it hit? For a very, very long time, the answer is nothing whatsoever. That beam would leave the planets behind in a few hours. Then it would cross the outer edge of the sun's influence. Then it would enter true interstellar space, the gap between the stars, and it would just keep going through dark so complete that along the way it would pass fewer atoms than you would find in a single whisper. It could travel for tens of thousands of years before it came anywhere close to another star, simply because almost nothing exists in that direction to get in its way. And this is the idea I really want you to take away, because it should rearrange how you see the night sky. When you look up, you imagine you are looking out at a universe full of things. You're not. You're looking across a void that is almost entirely empty space. The stars are not the universe. They are the rare exceptions sprinkled through it. The default state of the cosmos is not a star. It is the dark between the stars. And that dark is not just out along the plane. It is above you, below you, and in every single direction you are not looking. You live inside a thin sheet of specks, suspended in an ocean that has no shore, which raises one last question, and it is the one that flips this whole story on its head. Everything I've shown you so far frames the slowness of light as a curse, the thing that traps us, that makes the void feel infinite. But now I'm going to flip it completely, because there is a twist that changes everything. That same slowness, the thing that feels like a prison, is the only reason you know where you came from. Follow the logic with me. Light takes time to travel. So whenever you look at something far away, you're not seeing it as now. You're seeing the light that left it long ago. Every time you look out into space, you're looking back in time. When you look at the nearest star, you're seeing the light that left it more than 4 years ago. Look deeper and the effect snowballs. The light from distant galaxies has been traveling for millions of years, and some of the faint smudges in our most powerful telescopes left their source over 13 billion years ago, back when the universe itself was barely born. So think about what that exactly makes our telescopes. They're not really cameras, they're time machines. The deeper you look into space, the further back in time you see. We can watch galaxies in the act of forming. We can't see the universe in its infancy because that ancient light is only just arriving. Now, here is the question that locks it all together. What if light were instant? Suppose it crossed any distance in zero time. No delay, no crawl. Sounds like an upgrade, right? It would actually be a catastrophe for everything we know. If light were instant, every telescope would only ever show you the present moment. You would look out and see the universe exactly as it is right now, with zero record of how it got that way. The deep past would be invisible. No watching galaxies grow. No tracking the cosmos back toward its beginning. No evidence of the explosion that started it all. The entire history of the universe would be erased the instant it happened. So flip your view of the whole thing. The slowness of light is not just an obstacle. It is the universe keeping its own records. That maddening crawl is also the only reason you can look up and read your own origin story written in the dark. So let me leave you with the truth that flat map could never tell you. What fills the universe is not its stars. It is the distance between them. And light, the fastest thing physics allows, is just the tired messenger crawling across that distance, spending years or centuries or billions of years trying to connect these scattered, lonely points, carrying the only news the universe ever sends. So the next time someone shows you that little neat diagram of the solar system, you'll know better. You do not live in a crowded cosmos. You live on one bright grain in a thin, tiny sheet of grains, floating in an ocean of nothing, watching ancient light arrive from islands you will almost certainly never reach. Here's something to try tonight. Step outside and look up. Really look. The light landing in your eyes and those stars left them long before you were born. Some of it left before there were cities, before there was writing, before there were people at all. You're not looking at the night sky. You're looking at a graveyard of moments all arriving at once. So, tell me in the comments, does that make you feel safe, tucked away on your quiet little grain? Or does it make you feel exposed, adrift in a dark that goes on forever? I genuinely want to know which one it is for you because I think it says a lot about how a person sees the universe. And before you go, here is one thing about all this emptiness that still makes no sense. It's freezing out there. The sun is a furnace and the galaxy holds billions more stars just like it, all blazing away. So how can a universe packed with that much fire stay among the coldest places that exist? The answer comes straight out of everything you just learned about the void. We made a whole video on it, and it is on screen right now. Go watch it, and I'll see you out there in the dark.